Hello everyone. Let us have a brief discussion on the topic sets in the mathematics. So what exactly this video provides? So this provides a comprehension, a view on the topic of sets and how we represent the top concept of sets in a real life and how we use the concept of sets. So now let us start with what exactly is a set. A set is a collection of well-defined objects or elements. So this is just a collection of an objects. It doesn't talk about whether they are ordered or they are maybe they may be ordered, they are not ordered, but these are like similar type of objects. Okay, sets are defined by their elements, not by the order. So as we just talked about, here the order doesn't matter. So for example, when we talk of numbers, we talk about ascending order and descending order. Here we doesn't have the set doesn't matter all the ordering. So these are sets can be finite or infinite. So let us take an example of we usually talk about in mathematics natural numbers, set of natural numbers, or set of rational numbers, set of irrational numbers. These are infinite, right? And we also talk about set of alphabet, which are finite. Okay, so it can be finite or infinite. As we spoke about, the order doesn't matter and duplicates are not allowed. So when we talk about a set of natural numbers, here it does not have 1 1 or 2 2. It does not repeat the same number in the set. It just have single. It will be repeated only once. Even though we write twice, it will be considered as a one element. So as we move on, so we'll understand the applications where exactly we use the concept sets. Sets are used to represent group of things with common characters. Okay, so we just group the commonality things into one set or one category, we can say. So the best example could be, so when you go out for a shopping, you will just try to list out all the things. So that will be one set where you need to buy all those things. And another example could be when you enter a shopping mall, you will just see one side there will be a set of kids wear, set of men's wear one side. So in that way, so all those are considered to be as sets. Sets are fundamental in various fields. For example, when we talk about relations, sets relation is performed on sets. Okay, so when we talk about relation, so this particular set is having a relation between another set. So in those terms, we'll definitely use the concept of sets. And also in functions. So as we know, relations extension of relations is a function. So basically, function is defined from a domain and a range. So all the domains and range are normally a set. Okay, function is defined from a set of natural numbers to a set of natural numbers. So here domain will be a set of natural numbers, and range is also from a set of natural numbers. Okay, so we also use set concepts of set in the logic. Okay, sets are used to represent propositions and truth values. So for example, set we define a set as 1 comma 0 comma 1 comma 0 comma 1 comma 0 comma. So 0 and 1 are the truth values. So that will become a set. Okay. So in a simple terms, sets are similar to a list, but it does not allow duplicates. In the list, we may have duplicates, and we might have order in the list also, but here we doesn't have any specific order. So let us delve into the examples and how you analyze the concept of sets. Okay, so the best example would be from a set of alphabet, we have taken a set ovals which contains a, e, I, o, u. Okay, this is a set taken from a set of alphabet. Okay, so set of alphabet is also a set, and from that set we have taken a part of set which we will call it as a vowels, and Set of consonant is also a set. Okay, so these are subsets of set of alphabets. Okay, in a real life scenario where sets are used, or mainly we use sets in machine learning as a data sets will which we use to train the algorithms for the computation or analysis purposes. Okay, so and how you visualize the concept of sets is using Venn diagrams. So we actually use Venn diagrams to represent a set and the relation between the two sets. Okay, and now let us discuss about the what are the operations that are performed on the sets. First one is the union operation. So union operation is defined as it will basically get all the elements from the sets, okay, that are in which union is being performed. Okay, so let us take set A and set B. When we talk about A union B, so it will take elements from A, it will also take elements from B and the common elements that are present in A. So it is defined as the collection of elements which are in set A or in set B or in both A union B. Okay, so it will take elements from A, B and the common element that are present in it. The next operation that we talk about here is the insertion or intersection operation. So intersection is like the common elements that are present in the set A and set B. So it will take only the common elements, not other elements. Okay, it will just take only the common elements, the collection of elements which are present in both set A and B. Okay, so this is intersection. And next we talk about the complement of a set. So when we talk about complement of a set, it will be the elements that are present outside the set A and not in set A. Okay, so let us talk about like it does not consider the elements in set A. Other than set A elements, what are the present in A, what are not present in A, it will take into consideration. Okay, and some more operations such as some more properties that are present in sets are like commutative property, associative property and distributive property. So commutative property is like A union B is B union A, that's the commutative property. And associativity, we know associativity is like A union B union C is the same as A union B union C. Okay, so distribution of properties also holds between the intersection and the union. So these are the different operations and the that can be performed on the sets. So now let us talk about the power set. So what exactly is a power set? So power set of a set A, which is denoted as P of A, is a collection of all the subsets of A. Okay, so as I spoke about subsets earlier, set of vowels is a subset of set alphabet. Okay, so in that way, a power set is a set of collection of all the subsets, all possible subsets that are present for a set A, including empty set and the set itself. Okay, so power set is a set of all the possible subsets, including empty set and the set itself. Okay, so best example, power set of set A comma B. So is first one is the empty set, which must be included, and set of A, set of B, and set of A comma B, which is a set itself. So this is the best example of a power set of a set. And so how to find how many powers, how many elements that are present in a power set for any given set? Okay, oh, it actually grows exponentially. So a set with n elements has a power set with 2 power n elements. So here a set A comma B has 2 elements. So the power set must have 2 power n, here is 2. So 2 power 2, which is 4. So we can see set of A comma B is equal to set of empty set of A, set of B, and set of A comma B, which has 4 elements. So in that way, we can compute for any given set with n elements, a power set will have 2 power n elements in it. Okay. So what are the applications? Power sets are basically used in probability, representing all the possible events that can occur. So when we take an event, So what are the possible events that can occur? Either it can happen, or some part of it can happen, or full event can happen. Okay, these are the most possible cases. Okay, so in that cases we use actually power sets, and in a similar way we use in data structures and algorithms when we deal with combinations. So again, combinations come in the concept of probability. Okay, that's all for the day. Thank you.